The sum is limit of x plus x square plus x cube up to x raised to n minus n upon x minus 1 as x tends to 1 is. In the beginning only I'll tell you that limit cannot be just evaluated by replacing every x by 1, because in that case we get 1 plus 1 square, that is 1. So 1 plus 1 plus 1, how many times? N times. So if you add 1 n times, you get n minus n, that is 0. So 0 in the numerator. What about denominator? 1 minus 1, 0. 0 by 0 is an indeterminate form in mathematics. So the hint is use that result only. Limit, standard limit, limit x raised to n minus a raised to n upon x minus a as x tends to a is what? N into a raised to n minus. I'll give you some time. Just read the solution. So during that time you wouldn't be able to see me, you wouldn't be able to hear my voice, right? Okay, the time starts now. Okay, let me explain. Again, I'll tell you that this is an important sum. See, we have to find limit of this function, right? Now, can I write this n as 1 plus 1 plus 1 how many times? N times? The answer is yes. See, if you add 1 3 times, you get 1 plus 1 plus 1, 3. If you add 100 times, you get 100. And if you add 1 n times, you get what? N. Now, the next step is important. See, x square, x cube up to x raised to n. How many terms are there? N terms. So, I will give this minus 1 to each of these n terms. Why minus 1? Because there is minus sign before the bracket. So, x minus 1 I have put in one bracket. Then x square minus 1, x cube minus 1 up to what? Up to x raised to n minus 1. See, x plus x square plus x cube plus x raised to n as it is. Minus 1, minus 1, minus 1, how many times? N times. So minus n. Dear friends, we can write the same thing in different form, but we cannot and we should not write altogether different thing. Is that clear? And that is why I have written in this form. Okay. Now, the next step. What is limit of quotient? It is in fact, I have to split the numerator. I have not shown that here. After splitting the numerator, it is x minus 1 upon x minus 1, x square minus 1 upon x minus 1, up to what? X raised to n minus 1 upon x minus 1. And then I have to say limit of sum is sum of limits. I have shown this particular step directly. Now, this is what? Limit of x minus 1 upon x minus 1 as x tends to 1. Then x square minus, can I say 1 as 1 square? I can. No, why to say 1 square? Because index of x is 2, same should be the index of 1. Here I will say this is not 1, this is 1 cube. Actually, one and the same thing. Up to what? Here I can say what is the index of 1 here? Index of 1 is n. Note that this is again a standard limit. Now, here I have said what is limit of x raised to m minus 1 upon x minus 1? What is m? Any natural number. What is the value of this limit? I can replace this 1 by 1 raised to m. Now this is standard limit. The answer is m into tending value 1 raised to m minus 1. Note that 1 raised to m minus 1 is 1. So finally it is m into 1, that is m. So this is the general case now. After that I have written put m equal to 1, 2, 3 up to n in succession. I will explain this part again. See, this is the standard limit. Value of this limit is m. Now put m equal to 1. You get what? Limit of x minus 1 upon x minus 1 as x tends to 1. Yes, this is this one. Put x equal to 2. Limit of x square minus 1 upon x minus 1. Yes, this is the limit. Put x equal to 3. This is the limit. Up to what? N. Put x equal to n here, rather m equal to n here, you get this one. Now when you put m equal to 1, what is the answer? 1. So value of this limit is 1. What about second part? If you put m equal to 2, what is the answer? 2. Yes. For m equal to 3, answer is 3. And for this, what is the answer? N. In other words, the value of the limit is 1 plus 2 plus 3 up to n. This is not correct. So what is the value? 1 plus 2 plus 3 up to n. This is sum of the first n natural numbers. You have done this in arithmetic progression. In fact, you have done this in 10th standard only. Sum of the first n natural numbers is what? It is n into n plus 1 upon 2. Is that clear? So your final answer should be what? Final answer should be sigma r. R goes from 1 to n, which is nothing but n into n plus 1 upon 2. Hope you have understood the solution. Now we go to the next page. Okay. This is actually a combination of two functions. Limit of x cube plus root of x plus 2 minus 10 upon x square minus 4. Again, we cannot take the limit in the first step. Why? Because in that case we get 0 by 0 form. Observe this step. This is an important one. I have written x cube minus 10 as what? X cube minus 8 minus 2. Is this correct? Yes. I have written the same thing in different form, which is allowed. Now what is the advantage of splitting minus 10 as minus 8 and minus 2? In the next step, I can split the numerator to get limit of x cube minus 8 upon x square minus 4 as x tends to 2 plus limit of root of x plus 2 minus 2 upon x square minus 4. Now, here, what are the factors of a cube minus b cube? I have told you this many times that in the last step only you have to evaluate the limit. But in previous steps, you are supposed to simplify the given function. And for that, you have to use factorization formulae, trigonometry, and logarithm. Right? So, what are the factors of a cube minus b cube? They are a minus b, and other factor is a square plus ab plus b square. So, these are the factors of x cube minus 8. And what are the factors of x square minus 4? They are x minus 2 and x plus 2. Can I cancel x minus 2 here? The answer is yes, because x only tends to 2. X is not equal to 2. Now what about the second limit? It is better if we put this in a bracket. Here you have to realize that you have to rationalize. What is the rationalizing factor of root x plus 2 minus 2? It is root x plus 2 plus 2. We cannot just multiply numerator by that. We have to multiply denominator also by the same. Now, in the next step, see what happens. It is limit of x square plus 2x plus 4 upon x plus 2 after cancelling that factor. And in the second limit, what is square of root x plus 2? X plus 2 minus 2 square, which is 4, denominator as it is. Now, in the first limit, limit of quotient is limit of numerator. There should be plus sign here, right? So, limit of numerator, which is limit x square plus 2x plus 4 as x tends to 2 upon limit of denominator plus, see what happens, x plus 2 minus 4 is x minus 2. What about x square minus 4? The factors are x minus 2, x plus 2, this factor as it is. Now in the first limit, to take the limit means to replace every x by its limiting value, which is 2. So 2 square is 4 plus 4 plus 4 upon 2 plus 2. What about this? Can I cancel x minus 2? Yes, I can, because x only tends to 2, x is not equal to 2. Dear friends, you have to mention this whenever you cancel x minus 2. Now, this is 12 upon 4, which is eventually 3. What about this? What is limit of constant? That constant only in the denominator. To take the limit means to replace every x by its limiting value, which in this case is 2. So you can see this is 3 plus 1 upon 4 into 4, that is 3 plus 1 upon 16. LCM is 16, so 48 plus 1, 49. So what is the final answer? 49 upon 16. As I say that, you should mention final answer as what? L equals 49 divided by 16.